this is the topic I was given. Okay, well, my background is systems engineering, which means that I do modeling, and so probably somebody knew that when they gave me this title. My job today, as I see it, is to try and decode this and explain what I think this means in relation to deltas, all right? And and then most of the talk is going to be based on a study that I was involved with over 10 years or so on the Mekong, trying to prevent, well, let me put it a different way, trying to stop the building of dams on the mainstream, which would, in my view, kill the Mekong in terms of its biodiversity. And the Mekong is a really special river that you don't want to kill. So that's my job today. I have colleagues in the audience that know more than I do about everything I'm going to say. And so if I see them wave their hand, then I'll try and correct it, okay? Deltas, these are deltas. All right, so there's a lot of deltas in the world that are relevant to what we're talking about. And so it's not just the Mekong Delta that's of interest in general, but deltas are possible. And we've heard speakers before talk about some of the deltas, including just the last one. And deltas are a big deal, and especially with regard to these three outputs. And you've heard more about that in the previous speakers, so we don't need to waste time talking more about this. But the Mekong is certainly illustrates, or is a good example of the products that are produced by the deltas, okay? There are threats to the deltas, and the biggest threat, at least relevant to this talk, are dams. And it's a threat in terms of the dams being able to capture the sediment and the nutrients and stop the fish flowing in the river. And so if you like rivers and depend on rivers, as people do that live on the Mekong, dams are not helpful. You all know that what happens when a fish swims upstream and hits a dam? What's the fish say? Damn. You've heard that joke, okay. Yeah. But there are other threats, and this illustrates some of the threats and where they are in a quick way. And so, yeah, so managing deltas is important. I'm going to get finished here. The other one is, this shows the threats for population leaving the deltas due to sea level rise that they predict might happen by 2050. All right. So delta management is a challenge. And so what do we do? We can model this, and when we model it, we're trying to figure out, how things function, how they work. And if they're not working as well as we would like them to work, or in some ways not good, in some ways better, modeling is a process, in my biased view, of ways of trying to predict what will happen if you assume this or if you do this. And then you can make different assumptions and get a better understanding of how the system works, and the models can help you do that. The socio-ecological model is one that includes people, as well as the rest of ecology and the hydrology. And so it's common to diagram the system of systems that we're modeling, and to show the linkages between them. So here's a particular illustration of a model it's complex because the world is complex. It's supposed to be a joke, guys, okay? But it shows the complexity of everything, and it includes things that you're concerned about in a particular region. And so, as I've said, modeling can help us better understand the system, okay, and the impact that management options might have. The other thing that does, in my experience, which is very important and relevant to some of the talks that have occurred previously, is that models can, if there's a decent interface, can facilitate communication between stakeholders. And initially, when models became more than just text output, and we could see pictures of things, the danger was that people might believe the pictures. A model's a model, and we make assumptions that depend on, that govern how models work and what they produce. And so we have to be aware of that. Okay, but models can help. Models can facilitate communication. Okay, so now let's talk about the Mekong. This is the Mekong, guys. You've seen this before, right? So I don't need to talk about that much. And the Mekong's delta is at the bottom, and highlighted on the right is the Mekong Delta. You can see where we are today on that map. One thing that hasn't been shown that I've seen yet in this conference is the map showing the dams on the Mekong. And the Mekong's got a case of measles, okay? I mean, there's dams everywhere. And that's great from the point of view of what dams are supposed to produce. But again, dams can also be a detriment to the functioning of a natural, very important system. On the right are the mainstream dams that either exist or are being, or were being proposed. And I am going to focus on the study that we did over a long period of time on trying to make sure that those dams don't occur. But at the same time, provide the energy that the people in the region want and that expect, and that we're building dams to do. And these are hydropower dams. But first of all, this map shows, I think you can read it, shows the reduction in the sediment that has occurred now due to the dams that have been built upstream in the recent past. So you're getting about 50% of the sediment going into the Mekong Delta that would have gone, that 50% of what the sediment would have been if dams did not exist. And if you build all the dams that have been proposed and many people would like to build, you're not going to have much sediment at all. So you're going to have about more than 90% reduction in the sediment that goes on. And the sediment keeps the delta alive. So that's an important consideration. The dam that we focused on and were asked to focus on, and by the way, this was a project funded by the U.S. aid, so we can all mourn the loss of U.S. aid, okay, now. Is Samber Dam, which was a dam proposed at the very bottom of the lowest dam in the main stem river. And it's highlighted there. And I think the next slide shows how big this dam is. On the right is Hoover Dam in the United States. And those of us from the United States figured, if we're thinking about large dams, Hoover would be one of the dams that we might think about. And the width of the Hoover Dam is about 300 meters. And the width of the Samber Dam would be 18,000 meters. $5 billion to build. At that, 2 years ago, okay. And it would produce 2,600 megawatts of energy, which is good, which people want. So the challenge we had was to figure out how to avoid building that dam and still provide that energy for the region. And we had an adventure doing that, okay. So what's that? Okay. So what we did was to look at other sites and then do a lot of simulations to see how they worked, and what areas they flooded, and how much energy they produced. And we tried to get that 2600 target set, and we failed. We could not find an alternative that would replace the Samber Dam with respect to the energy that is being produced, proposed to be produced by the Samber Dam. So the person that ran this project was a lawyer, Greg Thomas, some of you know him, and it showed here, he, to do the best job that he felt he could do, he moved to Laos and lived there, and I would say got in bed with the government. And this is showing the government signing an MOU with Greg Thomas, and I'm told this is the first time the government signed an MOU with an NGO ever, in order to study and be tuned in politically to what's the needs are of the governments that are being affected. And the goals of our study was to maintain, if not maximize, three things. Okay, one is energy, and food, and that's fish, and ecological environmental security. Those were the goals. This is the delta, and you've all seen these statistics in previous talks, and how the Tonle Sap works. And if you built that Samber Dam, this wouldn't exist. The whole story here would not exist. It wouldn't be producing the rice and the fish and the flows in and out of Tonle Sap with the Samber Dam. For those that might not know this, I've been told that the fish migration in the Mekong includes about 1,100 different species. These data show that you've got 500 fish species passing that one point right there, which is the Samber Dam. So the Mekong's really a really unique situation. So what we did was to figure out how to generate energy and not build dams. Not build dams on the mainstream, or on the tributaries where fish were going. Now, some dams have been built, and it's a bloody disaster where they've been building, and that blocks the river at that point. And you can build dams upstream; it doesn't hurt the fish any because there's no fish. And so we're talking about preserving the natural river to the extent that it exists, but it doesn't mean not building dams. But what we did was to figure out what rules there might apply for siting, operating, and designing dams that would be sustainable and environmentally reasonable. Now, there was opposition to some extent. You can't do anything anywhere without somebody arguing against it. This is the minister of Cambodia arguing that he wanted Samber. And he was telling people that if they needed energy and they want to block that dam, he'll give them torches, light them for them, and they could go around in torches for the energy they need. And if they're worried about fish, they can go to a museum and look at fish. And so that's what he did. And I don't know if we had the impact or not. I don't know if our study made the impact or not. Probably other contributors as well. But the Samber Dam is now off the table until 2030. It doesn't mean that Samber won't be built in the future, but I can't believe anybody in their right mind would try to do that. 18,000 meter wide dam, 56 meters high. But anyway, but what we did discover was that a good alternative is to take the reservoirs that exist now and put solar panels on them. Thanks. I don't want to look at him. Okay. And the dams serve as a battery for the solar power. So when the sun's not shining, use the hydropower. When the sun is shining, let the hydropower dam fill to the extent that it would, and use the solar panels for the energy. And we did a lot of simulations of that. It's very technical, and it turns out that it seemed to me and to others that we found a way to help meet the energy demands that the region needs and wants, and not screw up the main river of the Mekong. And our feeling is that this study that we did, and that's relevant to the Mekong, is not only relevant to the Mekong, but it's relevant to a bunch of other deltas around the world. So my guy in charge, Greg Thomas, is hoping that the results of this study will be a motivator for other deltas in the world to think about other than building dams. Thanks, guys. See, I'm getting congratulated for ending on time.
Well, you can continue. You have time.
We owe you 5 minutes.